Yo kids, so this is the AS Unit 1 Physics A-Level paper from 2022, and I'm going to do each of the 7 questions separately. Question number 1 was your moments question. Let's go through it. The first 2 marks are just simple learn your notes in your book, state the conditions for a body to remain in equilibrium. If it's worth 2 marks, I obviously want 2 things. So you need to say the resultant force must be 0. And the resultant moment must be 0, or the anti-clockwise moment equals the clockwise, right? Nice and easy. Learn all your 1 and 2 mark definitions. Into the actual moments then. So this year they decided to put a clothes hanger with like a suit cover hanging from it. Straight away, turn that silly diagram into something we're used to seeing on the board in class, right? It tells us that when the clothes carrier supports a coat weighing 11.8 newtons at its centre. So there's my 11.8 newtons at the centre. Also coming out of the rod, I have the weight of the rod mg. It says a force of 8 newtons is exerted on each end, right? So I got 2 8s going up. I got this 11.8 coming down plus the weight of the rod. Well, obviously, everything up equals everything down because it's in equilibrium. Here's 16 newtons. So this needs to be 16 newtons going down, which gives the weight of the rod itself is 4.2 newtons, right? No problem with that. That's easy, only 2 marks. On to the 5 marker then, which is a bit more complex. Again, nothing you can't handle that you've done in class. Turn that diagram into one that you're used to seeing on the board in my room, okay? So it says the coat is now moved to a new position, and a jacket weighing 7.2 is hung from the beam, all of which is shown below. So let's turn all of that into this nice easy diagram, right? They've told us that the length of the rod holding the coats is 1.8 meters. We've worked out that the weight of the rod acting through the center is 4.2. They've told us the big coat is 11.8 newtons and 15 centimeters away from this side. Note I've put it in meters. They've told us the little coat is 7.2 newtons and it's 40 centimeters away from this side. Again, note that I've put it in centimeters. And they've asked us to calculate the 2 reaction forces at A and B, right? So this is a bog standard moments question. We've done it a million times. Take moments from here first to eliminate that one. Okay, so everything clockwise from here. The 7.2 newtons is going clockwise and it's that far away, so multiply them. The weight of the beam itself is trying to spin the system clockwise and it's halfway along, so that's 0.9 meters away. Multiply them together. And the large coat is 11.8 newtons trying to spin it clockwise, and it's 1.8 take away 0.15, which is 1.65 meters away. Multiply them. Add all of them up. That gives you the total clockwise moment trying to spin it that way. The only thing trying to spin it anti-clockwise is this reaction force at B, and that's 1.8 meters away from point A, so multiply them together. Because it's an equilibrium, the sum of these 3 must equal this, so add all of those up. It came to 26.13, then take the times by 1.8 over as a divide, and it came to 14.5 newtons. So the reaction at A is 14.5 newtons. Now you can either do exactly the same process again. The reaction at B is 14.5 newtons. You can either do exactly the same process again, take moments from here, and you'll find out reaction at A. But that's a bit daft because we know everything up equals everything down. We know the 3 things coming down. We now know one of the 2 things going up. So that allows me to work out F of A. So this plus the 14.5 we just worked out is going up. All of these 3 are coming down. So add those up. Take away the 14.5 and you get 8.7 newtons. Sorry, it wasn't on screen. You get 8.7 newtons there for the reaction at A. Nice bog standard moments question. I remember my year 13 last year struggled a bit with this. The key was turning that silly diagram into one you used to see a million times before on my board. Nice one.